All right, this video is just another example of Hess's law. Just reminding you, Hess's law is just another way to calculate the delta H for a reaction. So in bold here, I call this the target reaction. It's the reaction that maybe I don't have the delta H for, but I do have this other data below, which is the subreactions, the steps of that happen to give me the target reaction. And then I know that I can multiply the reactions by numbers, and then I also multiply my delta H by that same number. I can also reverse reactions, and if I reverse the sign. So the first thing I do, just my way of teaching it, is I find similar things in the target reaction as is the same things that are in the other subreactions. So I'm calling these the subreactions, the data that I have. So I can see the boron there matches. I'm going to match this B2H6 right here. And then I'm also going to match my hydrogen. So you can see that I have hydrogen here and I have hydrogen here. And then I am going to have to deal with that last reaction, even though nothing matched into the target, but you'll see as you're working that why it's necessary. So just in general, you can look at these and see that this one is 2 boron and 2 boron matches perfectly. So that first reaction, we're going to write it exactly how it is, and we are not going to change the delta H. We're not going to change the sign or anything. Okay, the next reaction, you can see this is a reactant, this is a product, so that's one I do need to reverse. So I'm going to put my 3 waters, and I'm going to keep track of the state of matter here because it does end up mattering. And then I get my 3 O2s, and then I get that B2H6. So I don't have to multiply the reaction because it's 1 mole of each. But I am going to change the sign on the delta H to positive. And then the hydrogen reaction, you can see that we have 3 moles in the target and only 1 here. So this reaction and this delta H need to be multiplied by 3. So that would give me 3 hydrogens, 3 halves oxygen, and 3 waters, and those have to be liquid. So I also need to multiply my delta H by 3, so I get negative 855. So you can kind of see, like you can start to try to cancel things, and you'll notice that the water, I have water, and I can't cancel the gas water with the liquid water because they're not the same state of matter. So that's where I'm going to use this last reaction. And it's written in the correct order because if I have the liquid water on over here on the reactant side, it can cancel with the liquid water that's on the product side. And the water, yeah, I think you can see it. So the only thing is we'd have to multiply that reaction by 3. So I would end up with 3 liquid waters, moles of liquid water, and then I would get 3 moles of steam, and then my delta H would also get multiplied by 3 and become 132. So now I'm ready to cancel, and when I add my delta H's, I get 38, and then as I'm adding the reactions, I'm trying to cancel everything, and then hopefully we'll end up with this reaction again. If not, then I know I did something wrong. So it's a good way, like doing the problem checks itself. So I'm going to start canceling. So I can cancel this B2O3. I can cancel the liquid water. I can also cancel the gas of water. And then I have quite a bit going on with the O2s. So I'm actually going to bring everything down right now one time, and then I'm going to simplify it from there. Some people bring everything down and then they start to cross out. But this is kind of an in-between. So I'm going to take what didn't cancel right now. So I have this from the first reaction still left. I have 3 hydrogens, another 3/2 oxygen. So everything that would be on the reactant side that didn't cancel so far, because I do have to cancel more, but then I have 3 moles of oxygen, the B2H6 over here. So what I'm really doing now is I have to cancel out my oxygens, or simplify it. So I have 3 halves and 3 halves, so 6 halves, or a total of 3 moles of oxygen here. So that is how I can cancel them. So these two will cancel this one. So that leaves me with the 2 borons plus the 3 hydrogens gives me B2H6, and my delta H is 38. So that total reaction is endothermic. If I were going to write this, I would put it on the reactant side. And we can again double check. Look, it matches. Fun.